Dear students, let us start with our another lecture which falls under the alignment design, that is module 3. In the previous interaction, we discussed about the summit curves. We talked about what are the various conditions under which the summit curves may be required, and towards the end we discussed that what are the ways in which the length of the summit curve can be calculated. And there we talked about that this length can be defined on the basis of either the overtaking side distance or the safe stopping side distance. So, in today's interaction, what are the things which we are going to cover? We will continue with the summit curves and we will see that how the other things are also being done, and then we will shift to the valley curves, and these two curves will constitute the vertical curves. After that, we will take up grid compensation, and then we will try to finish up the hairpin bends also. Let us start back with the summit curves now. Now, if you remember, in the previous interaction we discussed about the calculation of the length, and this calculation of the length has been with respect to SSD as well as with respect to OSD. Now, whatever is the case, in either of those conditions, again there are going to be two cases which we try to consider and see that which particular one is fitting in the given conditions where the vertical curve, or here in this case the summit curve, is to be provided. So, one case is that we are considering or assuming that the length of the curve is more than the SSD. By another case we say that the length of curve is less than SSD, and the same thing is with respect to OSD also. And when we have talked about these heights which are being defined here as capital S, small h, that is the height of the eye level and height of the object, and using those values what we have found is that when L is greater than SSD, then the formula is ns square divided by 4.4, but when L is less than SSD, then it becomes 2s minus 4.4 divided by n. And similarly, in the case of OSD, it is ns square divided by 9.6 if the length is more than OSD, but if it is less than OSD, then it is 2s minus 9.6 divided by n. Now, how you are going to utilize it is that first of all you make an assumption, say the assumption is being made then the length is greater than SSD, or if you are working with OSD the length is greater than OSD, and using this formula we will calculate the value and see whether this is being satisfied or not. If it is not being satisfied, then we will shift to the another assumption. Now, the one another thing which may happen is that when you have used both of the formula either for OSD or SSD, none of them is getting satisfied, or you may be getting the negative values. This may happen in either of the formula, or this may happen that in both of the cases either for OSD and SSD you are not getting the thing satisfied, and therefore, you have to take a decision. Now, what this tries to signify is that there is no requirement of providing the vertical curve. If both of the conditions are not getting satisfied, then this may be a reason, and the reason is coming out because of the angle of intersection where you are considering the value of n. And if this value of n is quite small, and if you remember when we talked about the minimum lengths which are required in the case of vertical curves, there we did talk about what is that maximum value of the grade change in percent which will require for providing a curve or not providing a curve, and that was also looked at in the case of expressway, but in terms of the minimum that grade change which will require it. So, in such cases what we need to do is we have to provide a some length of that curve, and that length is going to vary between 15 meters to 60 meters, again if you remember that table or you can refer back that, and this 15 meter and 60 meter are correlated with 35 kilometers per hour speed and 100 kilometers per hour speed. So, in between you can either interpolate the values, or otherwise you can take the values from the table which is already available. Now, when we talk about this summit curve and when said that this is the way it is being provided, now what is the location of this particular highest point is what we are talking. So, when I am looking at this, then this is 1 in n1 and this is 1 in n2, and we have this deviation as n, and the length of the curve from this point to this point is going to be L. So, when we have to find out that where this particular point is going to fall is that this is going to appear at a distance of n 1 into L divided by n, and this point is going to be at a distance n L divided by 8. So, this is an offset which will be there with respect to the point of intersection. This is point of intersection. So, this value is n L divided by 8. Now, this can also be utilized so as to work in the field and find out the reduced levels. Say if you have a reduced level of this point A available as RL1, then what you can do is that with the help of this 1 in N1 you can find out the reduced level of Pi, and from there if you use this ordinate and reduce the values. So, you have RL of Pi minus NL by 8 is going to be the reduced level of highest point. So, this is also the another utility of working with what we have just looked at. Now, let us have an example here. We have been provided with an upgradient of 1 in 100. So, there is a 1 in 100 and it meets a downgrade again of 1 in 100. So, this is also 1 in 100. This is being defined as national highway. So, national highway means once you are talking about national highway, and if the terrain is also being defined, then you can very easily find out what is going to be the design speed for it, and for that particular design speed then you can calculate the values of SSD and OSD if they have not been given to you. Now, here we have to calculate the length of the summit curve which is going in this form. So, this length is required, and the two cases are there. One is that the SSD is 180 meters, another one is that the overtaking side distance is 640 meters, and if we consider these two values, they are correlated with the speed of 100 kilometers per hour. You can go back and look at the table where the design speeds were discussed. Now, it is asking to first of all the length. The another one which is asking is what is the RL of the highest point on the summit curve if the RL of the tangent point at the start of the curve is 100 meters. So, what it says is at this point RL is 100 meters. Now, we have to find out the RL of the highest point which is here. So, what is the RL here? So, these are the requirements. The very first thing which we have to find out is this capital N, the deviation angle, and this deviation angle in this case, because you have an upgrade. So, this is upgrade is plus N1 minus, and there is a downgrade. So, minus N2. So, this is nothing but N1 plus N2. So, we have this 1 by 100 plus 1 by 100. So, you are going to get a value of 2% here. Now, if SSD is being given, let us assume for that, and we assume that L is greater than SSD, N is known to us, S is as 180 meters, and the rest of the values if we transform it into the constant based on their constant values as 1.2 meters and 0.15 meters respectively, this is the formula which we get. So, if we put the values in this one, what we get is we get 147.27 meters, and this 147.27 meters is not more than 180 meters. So, it is not okay. So, we have to go to the next equation, and that is the assumption here is the length is less than SSD, and again the formula is 2s minus 4.4 divided by n, and when we put the values in this one, what we get is the length is 140 meters. So, the assumption is being satisfied, and therefore, this is okay. Similarly, we can do it for OSD, and say we say that the length is going to be more than OSD, and the equation is ns square divided by 9.6. So, if we put the values here, what we get is 853.3 meters, and if this is the case, then obviously it is being satisfied, and therefore, this stops here. So, if we have to go for a summit curve so as to satisfy the safe stopping side distance only, then we can go for 140 meters. But if we are also assuming that overtaking is to be provided, then we have to think of a 850 meters around to be considered as the length of the curve in this case. Now, the another point which was that what is the highest point and its RL. So, the highest point is at N1 into L divided by N. So, it is at 70 meters from the start of the curve, that is tangent point, and here we are considering it for SSD. Now, the RL of the point of intersection will be what? That is going to be found out on the basis of 1 in N1, where it is a straight profile. So, it is 100 plus 1 by 100 into 70. So, what you get is 100.700 meters, and from there if we reduce the ordinate or the offset, that is NL by 8, we get it as 100.350 meters. So, this is the value which is going to be there as RL of the highest point. Now, there is another example here. Now, in this example again we have an upgradient, but this upgradient is 1 in 200 and it is meeting a down gradient, and this down gradient is again 1 in 200. Now, there is no necessity that all of these gradients they are going to be symmetrical, they can be any unsymmetrical values also. So, same national highway we are talking, we have to calculate the length of the summit curve if the safe stopping side distance to be provided is 180 meters. So, in this case first of all let us calculate the deviation angle again, and this deviation angle is now n 1 plus n 2. So, it is 1 by 200 plus 1 by 200. So, it is comes out to be 1% or 1 by 100, and now we go with the assumption that the length is greater than SSD, and if we put the values in this equation what we get is 73.64, but this is not greater than SSD, therefore, it is not okay. So, we go to the next equation here, and when we put the values here in 2s minus 4.4 divided by n, what we are getting is a negative value, and therefore, this is also not okay. So, what we have found is both of these conditions are not resulting in any of the length of a summit curve, and this may be because of the deviation angle, this may be because of the speeds, this may be because of the gradients which have been given here, and considering those, then we have to go back and see that what needs to be provided in these type of circumstances, and we take a decision maybe that we are going to provide a minimum length of 60 meters in this case, because we are talking about 180 meters here as is SSD, and this is related with 100 kilometers per hour speed. So, considering that particular speed, the minimum length required is 60 meters to be provided from the table, and that can be implemented. So, here the minimum lengths have been defined. So, different cases are there. So, they are being defined on the basis of say two values which are NL by 8, and this NL by 8 is nothing but as we discussed previously, that is an ordinate from the point of intersection to the highest point on the curve. So, if we consider a value of simple 0.3 at a minimum level or 0.6 at a minimum level, 0.3 when we are considering it is when the length is less than SSD, and when the length is greater than SSD, the minimum value is 0.6. So, here for the different values of the speeds, we get the different values of the lengths to be provided, and in these cases when these lengths are there, then the value of n as you can see is changing in this form. So, when we have provided a length of 130 meters at a speed of 100 kilometers per hour, what you can see here is that the n is 0.018, which is greater than 0.01, which was the case in the previous example, and where we could not provide the length of the curve, and we have to go for a minimum values to be provided. The same is the case here, where the values are changing from 30 meters to 195 meters for a speed of 30 to 100 kilometers per hour, and here too the values of n's are being given, and this also you can see that this value of n is quite high, like it is 2.5%, which is there for this particular value, and where you are going to provide a length as 195 meters. The Indian Road Congress in its guidelines also provides you the curves, and in these curves, like on this particular side there is a length, on this side is the deviation angle, and then we have different curves. So, this curve or this curve, they are all related with the speeds, whereas this curve or this curve, they are related with the ordinate values. So, either is the condition, whatever condition you have, on the basis of that you can identify that what needs to be done. Say if you have a deviation angle of even 2%, so that is here, and you have a speed of 100 kilometers per hour, then maybe you are requiring to provide somewhere around 140 meters as a length, and that is what, if you remember, we calculated in the first example which we have just solved. This is a case where we are talking about ISD, that is intermediate side distance, and this ISD is 2 times of SSD. So, here again we have length, and on this side we have deviation angle. And if we talk about say again 100 kilometers per hour speed, what we found is that still it is beyond 0.01. So, you are not requiring to provide a summit curve if you have a value which is somewhere less than roughly around 0.013 or 0.014 as an N value. So, this is how actually we have to look at it, and when you look at this dotted line, this dotted line means below it we are talking about for a length less than ISD, and above that we are talking about a length greater than ISD. Similarly, here also we have for OSD, the same conditions are there. We have N on this side, we have length on this particular side, we have the speeds here, or we have the ordinates in these cases, and then again we have a dotted line, and this dotted line says that if you are on this side then it is greater than condition, if you are on this side then this is less than condition, and that is how you are going to get the values of OSD. So, you can directly borrow the values from these particular curves which have already been specified and being given. Now, let us move to the next type of a curve, which is a valley curve. Now, this valley curve is being formed when a downward gradient meets an upward gradient. This can be one case, or there can be a downward gradient which is meeting and another downward gradient, but it is flatter in nature, or so on. But only thing which we have to see is that there is going to be a sort of a concavity downwards, and in that case we are going to have a valley curve, and this valley curve can also be defined as a seg curve. Now, if you look at it, so this is down gradient and this is also down gradient. So, you have minus N1 and minus N2, and that is why when you talk about this, then this is minus N1 and minus N2, and that is where it becomes N2 minus N1. The other case is again this is down and this is flat condition, or this is a downgrade with an upgrade, or there is a flatter upgrade with a steeper upgrade. So, all of these things are going to create a condition for a valley curve, and we can also have, as we discussed in the case of the summit curves too, that if we have a upgrade here which is following the flat condition, then in this case also we are going to have a valley curve, and this is going to be N. So, here this N1 is 0 and this is positive N2. So, you are going to get the values accordingly. Okay. So, this is N is equals to N1 minus N2. So, this is the value which we will have. Now, when we are talking about this type of a curve, what are the issues which are going to be there, and because of those issues, then what becomes the criteria for the design of a valley curve, that is what we are going to talk about. So, when we are having this sort of an issue, so very first thing that it says is that the vehicle negotiates a valley curve, there is no issue of a visibility, because you are going in this form. So, you have been able to see everything which is happening in front of you, but this is when you are talking about a daytime. When you are talking about a night time and you are moving in this direction, so the light is coming out here and there is going to be a beam. So, you will be able to see up to that particular distance up to which the light beam is reaching, and this particular type of a distance is defined as, because it is related with the headlight. So, it is defined as headlight sight distance. So, this is one criteria which is to be considered, and that is specifically for nighttime driving. But whatever is the case, whatever is the criteria, we are going to consider the minimum length which has to be provided shall be SSD, and that length has to be available all along this point when you are looking at this. So, this has to be minimum SSD, but by any of the criteria, if you get a value more than this SSD, then we are going to provide that particular value. So, whatever is higher, we are going to look at it. Now, another issue is when this vehicle is moving in this form, what are the things which are going to happen? So, the things are that when this vehicle comes to typically this situation, then there is a force which is acting in this direction. So, this is a centrifugal force. At the same time, the weight is also acting in the downward direction. So, the weight and the centrifugal force, when they act in the downward direction, then what happens is there is a more of pressure on the suspension system, and because of this there is going to be a sort of a discomfort, and that is where we also need to look at the comfort criteria. So, this comfort criteria is going to be based on this centrifugal force. So, the rate of change of centrifugal force becomes another criteria. So, we have two criterias now. One is related to HLST, another is related to the rate of change of centrifugal acceleration, and we have to see that the length which we are going to provide should satisfy both of these, and that is the value is going to be provided as the length of the Rayleigh curve. So, the same things have been defined here. So, we are talking like the centrifugal force, we are talking the weight, and therefore, the pressure on this, that is R A and R B on the two wheels, the front axle and the back axle condition or the rear axle condition. So, that is going to be quite high, and therefore, when it tries to negotiate in this form, so it is working against the combination of these forces, and that is the reason of the discomfort. Okay, so, when we are looking at this and when we are trying to resolve it, then what we say is that this is the headlight location. So, if I say that I have a vehicle here, so this vehicle is something like this. So, we have a headlight at this particular location, and from here whatever the light is coming out, this beam makes an angle alpha with that particular light, and therefore, we have been able to see up to this point, and that is what we are trying to find it out, that how this length is going to be calculated. So, considering these things, we are going to find that what is the formula when we are looking at the headlight side distance. Now, when we are going to provide this curve, the another point is that what is the shape of the curve, and the shape of the curve is either spiral or cubic parabola, and in case of the comfort condition, it is a combination of the two parabolas. So, that means when you are talking about a curve being provided like this with respect to the condition in this form. So, we have one length here and we have another length here. So, these are the two lengths which we are going to consider, and the total length is nothing but 2 L1. So, let us see the case of the comfort condition. Now, in the case of comfort condition, we have looked at this formula, that is n v cube divided by c. So, this n v cube divided by c is being utilized here. The only change which is there is because now you are talking about the double of the length. So, you have 2 times of it, and this is an under root of it of this value, where c is not being calculated by your formula, but it is actually being taken as a constant value, and that is 0.6 meter per second cube. So, when we put these values here, you are going to get the n is the deviation angle, and v you are going to have a speed in meter per second, and that is how you have the values. The another case is a headlight side distance, where we are going to consider two things. One is the height of the headlight. So, this is height of headlight above surface, and another is the angle alpha, which is angle of beam with respect to the horizontal. So, if we consider these things, what we are going to get as a formula again for the two conditions, that is the assumption is whether the length is greater than s or the length is less than s when you are talking about the SSD. So, it becomes n s square divided by a combination of 1.5 plus 0.035 s, where when we say 1.5 is basically 2 h1. So, it is 2 into 0.75, and 10 alpha is 1 degree, and with respect to that you are going to get these values. Similarly, when L is less than the SSD, then it is 2 s minus 1.5 plus 0.035 s divided by n. So, these are the two formula we are going to utilize to find out the length. So, the things have been defined here, whatever the notations have been used, and I have already defined these notations to you. Of course, only one thing which is going to remain in this one is that this S, if this S is not being given, then this is going to be correlated with V, and this V can also be correlated with the road type in a terrain. So, we have to take a decision in this form if this value is not available. Let us look at this example. So, we are going to calculate the length of the valley curve on a state highway where the vehicles are operating at a speed of 80 kilometers per hour. The curve is formed and there is a down gradient of 1 in 30, which is meeting an up gradient of 1 in 20. So, this is a negative gradient and this is a positive gradient as n1 and n2. So, when we utilize them, so it is minus n1 minus n2. So, it is minus condition. So, what we get is minus 1 by 30 minus 1 by 20, and this comes out to be 1 by 12 as a negative value, but this negative value we are not considering because the absolute value of that n is going to be considered in the formula. So, that is why it was written as 1 divided by 12. So, for a comfort condition, this is the formula where C is being defined and we put the values of n as 1 by 12, is small v as 80 divided by 3.6 and cube of it, and C as 0.6, then we get is 78.08 meters. But when you are talking about an SSD, and this SSD at a speed of 80 kilometers per hour is 120 meters, which can be calculated, then assuming that the length is greater than S, we have this formula, and when we put the values in this formula, what we get is 210.53 meters. So, what we can do is we can provide the higher of these two values. So, both of the conditions can be satisfied, and that is where we are providing a value of 210 meters. So, again we have similar conditions, that is when you are talking about this side, then this is greater than condition or this is less than condition. Here on the y axis we have length, here on the x axis we have deviation angles, these are related to speeds. So, we can find out the length of the valley curve by use of these type of graphs also. Here the length of vertical curves have been defined for say a case of length is greater than S, where S can be SSD, ISD or OSD, and they have been defined for different speed values, and for these speed values they are being given in terms of n, where n is in percent. So, if you look at here, so if we are talking about say 2% change, which we have considered in one of the example for a speed of 100 kilometers per hour, then this comes out to be around 148 meters. We calculated there by the equation as 140 meters, and similarly if we talk about the OSD, then this comes out to be around 853 meters, and we also calculated around 853 meters in that case. So, that is how the values are going to be there, and this is a case of the valley curve when you are talking about HLST. Now, one another case which is there is that we need to do a grade compensation on curves. Now, why we are doing grade compensations? There are two things which are being talked together. One is gradient, the one is a curve. So, you are going up with respect to the horizontal, and at this point there is a curve being provided. So, a horizontal curve in plan is there and there is a vertical alignment in this form. So, when these two things are happening, so there are two type of resistances which are working. One is a grade resistance and another one is a resistance due to curvature. Now, grade resistance is already there because you cannot omit it. Now, what you can do is that whatever the things which are happening because of the curvature, can we reduce those effects, and that reduction of those effects of the curvature is being defined as that grade compensation, because you are now making eased out a grade by some extent, so that this can be offset. So, this when we are talking, when we are looking at a vehicle which is moving, say there is a vehicle like this, and this is the front axle and this one is the rear axle. So, in these cases when this is being connected in this form, usually in our Indian conditions we have a power unit at the rear axle. So, whatever is the torque which is working, this torque is working in the forward direction, and that is how the vehicle is moving ahead. Now, when there is a curvature along with this gradient, you are going up and then the curvature is there. So, what you do is you are going to steer your wheels. So, when you steer your wheels say at an angle alpha, then now the things are going to happen in this direction. So, we have t dash in this direction and there is a angle alpha at which the steering is being done. Now, this t dash which is there is actually nothing but it is t minus t cos alpha. So, there is a reduction in the torque which is going to be there in this direction, and because of this reduction now the vehicle will not be able to negotiate at that curve with the same efficiency which otherwise it could have done, and that is the reason that we have to take into consideration this grade compensation. So, this grade compensation is being done by estimation. That means you have the formula which is 30 plus r divided by r, where r is the radius of a circular curve, and at the same time there is a maximum value which can be there which is 75 divided by r. So, we have to consider both of these and see that what is applicable, but one thing which we have to take into consideration and keep it in mind is that the grades are not going to be eased beyond 4%. So, if you get any value after application of any of the grade compensation as less than 4%, then we are going to make it minimum 4% there. So, let us look at one example here. Now, in this example we have a longitudinal gradient of 5.5%. There is a circular curve of radius 200 meters. We have to see what needs to be done in this case. So, the grade compensation is 30 plus r by r with a maximum value as 75 by r. So, 30 plus r by r results in 1.15%, whereas maximum value is 0.375%. So, if we consider this maximum allowable value, what we get is 5.125%. That means, now instead of providing 5.5%, we are going to provide 5.125% in this particular situation being given, and that will help the vehicles to negotiate. Let us look at another example. Now, in this example we have a longitudinal gradient of 4.5% and the radius of the horizontal circular curve which is overlapping here is 100 meters. So, we have to see what is the compensated condition. So, the grade compensated in this case is going to be 30 plus r divided by r and 75 by r as we discussed already, and this results in two values. One is 1.3% and another is as a maximum permissible 0.75%. So, when we use this maximum permissible, then what you are going to get is 3.75%. But as I said, we are not easing the things beyond 4%, hence what we are going to provide is 4% as such. So, with this we close our interaction now, and we will be discussing the rest of the things. The one point which was left is the hairpin bends. We will be taking up that also in the next interaction. Till then, thank you and bye.